Alrighty, Roo, we are on lesson 18, advanced word problems. Let's jump right into it. Advanced word problems, we're just going to WP. We have to remember that the number of independent equations always equals the number of variables. Always, always, always. The number of independent equations equals the number of variables.
I need Christian Corella to the front desk. Please, Christian Corella to the front desk.
Sorry about that. So let's do an example. The number of blues was 4 less than the sum of the whites and the greens. Also, the number of greens equaled the sum of the blues and the whites. How many of each were there? If there were twice as many blues as whites. Okay, so each sentence is an equation. The number of blues was 4 less than the sum of the whites and the greens. Okay, also the number of greens is the sum of the blues and the whites. How many of each were there if there were twice as many blues as whites, which means B is 2W. So I'm going to take these equations and I'm just going to plug it in. B equals 2W, so I'm going to put that here. 2W equals W plus. Now I know that greens is B plus W, which is 2W plus W. And I can plug that in for greens here. So plus 3W minus 4. So I get 2W is 4W minus 4. I'm going to add the 4 to both sides and subtract 2W, leaving me with 4 equals 2W. So W equals 2. If W equals 2, then B's equal 4. And then greens equals 6. Okay? There's not much more to it than this. But let's do more examples. There's lots of different types. The quarters, nickels, and dimes totaled 20, and their value was $1.90. How many of each kind were there if there were 4 times as many nickels as quarters? All right, so we know that quarters plus nickels plus dimes totals 20. Their value was $1.90, so I know that quarters is 25 cents, nickels is 5 cents, and dimes is 10 cents. And their value is $1.90. And I also know that there were 4 times as many nickels as quarters, so N equals 4Q. All right, so I'm first going to multiply this equation by 100. Okay, so I get 25Q plus 5N plus 10D equals 190. And then I'm going to plug in 4Q for N here and for N here. So my two equations, I get 25Q plus 5 times 4Q plus 10D is 190. So this gives me 45Q plus 10D is 190. This is one equation. Then I will have Q plus 4Q plus D is 20. So 5q plus d is 20. That's my second equation. Now, I'm going to use elimination. Doesn't matter what you do. I'm going to multiply this equation by minus 10 and put it under here. So I will have minus 50q minus 10d equals minus 200. My d's cancel, leaving me with minus 5q is minus 10. So q is 2. 2 quarters, which means n is 8, which tells me that d is 12. Okay, the key is getting it down into smaller problems. Okay, let's do a new type of example. Okay, direct variation. We're just going to do an example. Reds varied directly as blues squared and inversely as greens. When there were 80 reds, there were 4 blues and 2 greens. How many reds were there when there were 8 blues and 10 greens? Okay, so variation, we always have a proportionality constant, which we call K, that we will have to solve for. So reds vary directly, which means I will have K times B squared, directly as blue squared. Inversely means I will have K over G, because they varied inversely as greens. Okay. Now, it tells me when there were 80 reds, so I plug in 80 for R, and I'm going to solve for K. There were 4 blues and 2 greens. So I get 160 equals 16K. So K is 10. K is my proportionality constant. So now I have R equals 10 blues squared over greens. And I want to know how many reds were there. So reds equals 10. 10 is my proportionality constant. It doesn't change. When there were 8 blues, so I plug in 8 here, and 10 greens. Well, lucky for us, our 10s cancel, and that gives me 64 reds. Okay. All right, we got a couple different types of problems, so hang in there. The sum of the digits of a 2-digit counting number is 5. When the digits are reversed, the number is 9 greater than the original. What was the original number? Okay, so the sum of the digits of a 2-digit counting number. 2-digit counting number means we have our tens place and our units place. Okay, and I'm adding those digits together, and it tells me that their sum is 5. Now, when the digits are reversed, that means instead of having a units place, I'm having a tens place, right? I'm reversing it. 10u plus t. Sorry, this should be a 10. Yep, that's right. 10u plus t. The digits are reversed is 9 greater than the original. The original is 10t plus u. Okay, here we're just summing up the digits, but here we're talking about the digits having their place value. Okay. Now I'm going to solve this top equation and say t is 5 minus u, which I'm going to plug in here. So I'll have 10u plus 5 minus u equals 9 plus 10 times 5 minus u plus u. So I get 9u plus 5 is 9 plus 50 minus 10u plus u. So 9u plus 5 equals 59 minus 9u. I'm going to subtract 5 from both sides, and I'm going to add 9u to both sides, giving me that 18u is 64, which shows me that u is 3. And if u is 3, I go back up to this equation and find that t is 2. Now that's not my answer, because my answer is a 2-digit counting number. So t is my tens place, u is my ones place, and my number is 23. Okay. All right, just a couple more examples. That was example 4. So here's example 5. Chemical mixture problems. To get 1,000 gallons of a mixture that was 56% alcohol, it was necessary to mix a quantity of 20% alcohol solution with a quantity of 80% alcohol solution. How much of each was required? So this is just like our nickel and dime problems. Okay, I have two solutions. I'm going to say X is my gallons of 56% alcohol, and Y is my gallons, of 20% alcohol, and Y is my gallons of 80% alcohol. And I know that I have 1,000 gallons of a mixture, so X plus Y gives me 1,000. Okay, now I know that X is 20% of a solution, Y is 80% of solution, and my final is a 56% solution. I have percent times amount plus percent times amount equals percent times amount. Amount plus amount equals amount. You have to keep it consistent. Okay, now I'm going to multiply this equation by 100. Giving me 20x plus 80y equals 56 times 1,000. You could multiply that out if you want. Okay. And I'm going to use elimination, so I'm going to multiply this equation by minus 20. So I have minus 20x minus 20y equals minus 20 times 1,000. If I add them together, these cancel, leaving me with 60y equals 36 times 8,000. And I divide both sides by 60. Giving me, if one of my zeros cancel, 36 divided by 6 is 6 times 100. Gives me 600 gallons of Y. Now I've already labeled my variable as Y is gallons of 80% solution, so I don't have to change it from here. I can just say Y is 600 gallons of that solution. Okay, if you did not label it, then you need to say of 80% solution. And then we know that X is 400 gallons. Okay. All right, 2 more examples. How many liters of a 64% glycol solution must be added to 77 liters of a 23% glycol solution to get a 42% solution? Okay, so I'm starting with I'm adding a 64% solution to a 77 liters of a 23% solution. So I have 23% solution and I have 77 liters of that. I'm adding to that a 64% solution of some amount of liters. I'm going to call it X. And I'm getting a 42% liter solution, and the liters that it is 77 plus X. I started with 77 and I'm adding X onto it. Okay. Now I'm going to multiply everything by 100, giving me 23 times 77 plus 64X equals 42 times 77 plus X. Okay, so you can multiply these out. We distribute here. And we get 23 times 77. I'll have 1771 plus 64X equals 42 times 77, which gives me 3234 plus 42X. I'm going to bring my 1771 over, and I'm going to bring my 42X over. And I will have 22X equals 1463 divided by 22. And I will be adding 66.5 liters of 64% solution. Okay? All right, last example. The weight of the carbon in the container of C3H7Cl, if you know the exact name for that, whoop-de-doo. I'm very excited. I don't know it. I'll have to look it up. And the weight of carbon was 113 grams. What is the total weight of the compound? And we are going to round to the nearest gram. Okay, now you will also be given that C is 12, H is 1, and Cl is 35, which is important because I have to find my weight of this compound, right? I have 3 carbons, which each weigh 12, so it gives me 36. I have 7 H's, each weigh 1, which gives me 7. And I have 1 chlorine, which weighs 35, giving me 35, a total of 78. Okay? So then I need to set up my ratios. I know that I have 36 carbons, so 36 out of my 78 is to carbons on top. I have 113 out of my total, and I'm looking for my total. So I cross multiply and I get 36T equals 78 times 113. Divide by 36, and I get T is 244.83 grams. Okay. The hardest part about these lessons is remembering all the different types of word problems you can have and how to manipulate all of them. But this lesson is a really good way to remember. Remember, if you have any questions, bring them to class and we will go over them. But for now, good luck on the rest of your homework.